I like to imagine things. I like to create things.
The uni course is a lot of fun actually. I found it great.
Engineering's a super job. The world's pretty much your oyster. You can go anywhere with engineering.
It's a lot of fun actually.
Take a good look around. An engineer played a major part in the buildings, the bridges, the roads and the machines that we use every day. Engineers create, they find solutions and they push the boundaries of science and technology. A career in engineering is exciting, it's fun, it's cool and it could take you anywhere in the world. Engineering involves using basic skills in maths and science to create something new that will hopefully benefit other people. It's a university degree course. This is Telstra Dome in Melbourne. It seats 56,000 people, all with uninterrupted views. AFL games are played here, rugby, soccer, and some of the biggest names in the music and entertainment industry have their concerts here. A couple of unique features. The seats on this side and on this side can actually slide in and out, depending on the event that's being held here. But most importantly, if it looks like rain, they can simply close over this gigantic roof and make a massive indoor stadium. And this was all made possible by Australian engineers.
Yeah, I started when I was only 9 months out of university and spent 2.5 years working on the project. Learned a lot of tricks of the trade down here. Structural engineering, which is the discipline that I work in, is essentially involved in the design of literally the structure required to support buildings. We work closely with architects and builders to come up with systems that will support the building that they're trying to achieve. Early on in the project I was involved in the design of the concrete superstructure, so the large concrete elements required to support all the seating tier, and as the project progressed I was involved more and more in the site activities, responding to the builders' queries, changes and things of that nature.
The key feature of the stadium is the roof.
Yeah, as I understand it, was certainly the largest moving roof over a sporting stadium in Australia and one of the largest in the world at the time of construction. We have 4 major trusses that support each of the edges of the fixed roof structure, which leaves a 100 metre by 150 metre opening above the playing surface. And then we have the moving roof which slides over the top of those to close that opening. The moving roof is supported by 8 sets of wheels, which we call bogies. The bogies actually drive the structure as well. It takes about 10 minutes to open and close the roof.
This feature allows all events to be held in ideal conditions, day or night, regardless of the weather outside.
I come here and watch footy with friends and everybody enjoys this experience, and sport is such a part of Melbourne culture, and to be a part of that is a great thing.
There's a little place called Yambuk on the coast of Victoria, about 300 kilometres west of Melbourne, which houses one of the most cutting-edge electricity generating plants in the country.
There's 20 wind turbines on this wind farm. They're 73 metres to the actual hub, the centre of the blades. From the centre of the blades to the tip of the blades is another 35 metres. So in total you've got 108 metres from the ground. The basic principles of wind farm is that the wind energy will be converted into a kinetic energy, and that in itself will then get transferred into electrical energy in the generator, and the generator is housed up in the top of the wind turbine. As a rule of thumb, a wind turbine of this size will generate enough electricity to run the equivalent of 1,000 homes. I was the eyes and ears of the client on site. So when there was engineering issues that came up, I would be in discussions with the head contractor about those issues and how they would be resolved. and communicating that to the client.
The concrete and steel foundations were made to withstand the massive forces generated by the wind.
In total there's about 260 cubic metres of concrete there, 60 to 70 truckloads of concrete that are delivered into the foundation. So it's a huge volume. Wind farms, they're basically renewable energy, so as long as the wind's blowing it's producing electricity. Yeah, it's great. It's good to be involved in projects that's got renewable energies, it's benefiting the community and it's not compromising the future generations. And yeah, it's great to see them spinning.
Now, sometimes engineers are asked to come up with solutions to very unique problems. On the New South Wales coast, this road between Clifton and Coalcliff was cut by rockfalls and landslides, effectively isolating the two centres. So a very talented group of engineers got their heads together and came up with this, the Seacliff Bridge on the Lawrence Hargrave Drive, the only bridge of its kind anywhere in the world, 651 metres of pure engineering brilliance. The new bridge is a vast contrast to the old road built into the hillside.
The road would be closed whenever there was over a certain level of rainfall because the road would become so unstable. And in August 2003, the road was officially closed after there was a very significant rockfall.
A group of consulting engineers came up with 26 options to solve the problem, including tunnelling through the hillside. But the bridge solution was thought to be the best.
Essentially, we shifted the road 30 metres away from the coastline out of the rockfall zone. My role was with the bridge design team. I was working under some very eminent engineers from around Australia and internationally, looking at the analysis of how we make this bridge stand up under the conditions that we're under. I was able to work on this as my first job out of uni, so to work under engineers with that much experience and that much talent was just taught me so much in such a short period of time.
The engineering team came up with a world-first method of construction, which involved building two bridges, joined in the middle.
In order to build one of the bridges, we brought in form travellers over from Europe, and essentially they sit at the supports and you build part of the bridge, and then once that part of the bridge is finished, they lift up on rails, move out, and then you start building the next section of the bridge. The other part of the bridge was built by incrementally launch, so you build part of the bridge in a casting yard, and then you jack it up and push it along its supports, and you keep doing that until it gets to the other end of the bridge. It's beautiful to look at, and it's just great to, to have been a part of.
State-of-the-art engineering was applied to create this unique building. Melbourne's Council House 2, or CH2. It's Australia's most environmentally friendly office building and one of the greenest buildings in the world.
We designed the skeleton of the building, the floor structure, the columns, the walls, the floors, how the building goes together and how it stands up.
All materials used in CH2 had the lowest possible energy consumption to produce. The concrete has a special additive which significantly reduces the cement content.
Now, cement production is a significant contributor to greenhouse gas emissions right around the world. So there's a massive benefit to the environment.
The recycled timber slats on the outside of the building move with the sun to provide shade, which helps cool the building. Sewage water is cleaned and chilled, then run through panels in the ceiling. This cools warm office air as it rises, circulating cool air through the building. 100% fresh air is ducted through the floor and exits through vents in the ceiling. Water falling through these shower towers cools the air within the tubes. This cool air is then used to air-condition shops at the bottom of the building. These clever engineering features result in electricity consumption being reduced by 85%. Water use is reduced by 72% and gas consumption by 87%.
Level 9.
The building will contribute significantly less greenhouse gas emissions to the atmosphere. The occupants will work and live in a healthy environment. The council is hoping that this flagship will set a very good example for other commercial developers. I feel very proud to be involved in a project like this.
Gerald Stewart often gets to work with rock stars and celebrities in his engineering job, designing studios for recording companies and radio stations.
I guess the difference between an acoustic engineer and a sound engineer is the acoustic engineer actually makes the environment and the sound engineer makes the sound. I got into it with a love of music. When I was about 9 years old, I had my first guitar.
Gerald designed this state-of-the-art mastering DVD authoring studio at Sony BMG in Sydney. It's used to produce 5.1 surround sound for DVDs. The aim of the design was to make the sound as smooth and clear as possible right in front of the console, where the sound engineer sits when mixing music through the 6 speakers.
The room is designed so that it actually moves bad sound, for want of a better word, to somewhere other than where the engineer is sitting.
The walls and ceiling have special shapes and surfaces that either reflect or absorb sound waves to create that perfect sweet spot right in front of the console.
This jagged surface has got a slot in it, and the sound that it's going to take out is a dipping of my voice, and you can hear how that's actually sucking quite a lot of energy out of the low-mid frequency. Next one along is a full-range absorber. You can hear how it really softens and it deadens what would be a bright surface down to very dead.
The floor is flat and smooth, providing an unwanted reflective surface.
So the ceiling is actually developed up so that it actually reflects energy and reflects sound away from the floor. I guess from an engineering perspective, it's nice to look back and go, I did that.
People think that engineering is all about sitting in a quiet office, crunching numbers and writing reports. But I'm here to tell you that couldn't be further from the truth.
Oh, it's a great job. Well, I get to do many aspects of engineering, not what you would face in a normal engineering job.
Bob Tan heads up the engineering and maintenance team at Dreamworld on the Gold Coast. In his role, he spends his time travelling the world, finding the latest thrill rides, then supervises their construction and maintenance here at the park.
This job here is very different and we have many engineering challenges.
The Cyclone roller coaster is 13 stories high, 800 metres long and reaches speeds of more than 80 kilometres an hour. It had to be built strong and safe.
In a roller coaster, there are safety factors that range from about 3 to 10. In simple terms, is if it only needs to be so strong, it is between 3 to 10 times stronger. The track itself is sort of self-supporting between columns. You see, it's a little mini truss. The other thing you would note is that bolted connection. They are usually made up of multiple bolts, so that there is redundancy in if any of the bolts should break in time. The extreme load or pressure on the carriage is really at the point before it goes into the loop, because that's where the maximum change of direction occurs, and that's where the highest stresses occur.
Bob Tan is an engineer who loves to see people enjoying the result of his work.
It gives me a great sense of achievement when we finally commission a ride and complete the attraction, and the first lot of riders go through and come out smiling.
The Hay Point Coal Terminal near Mackay on Queensland's north coast stores coal from major mines, then loads it onto ships for export overseas. This massive site is a great training ground for young engineers.
I'm a mechanical engineer and I work with the design team, the people that design upgrades to the terminal. And I'm here supervising some construction, helping them sort out any issues that they have during construction. Engineering is really about problem solving. Being able to get out there and see where the issues are and sort a solution out is probably a very important skill. The stacker reclaimers here are very interesting from an engineering perspective. This is one of the largest stacker reclaimers in Australia. What it does is it places coal into a stockpile and then it can pick it up again, put it on a conveyor. This stacker reclaimer is capable of around about 4,500 tonnes per hour reclaiming and up to about 6,000 tonnes per hour when it's stacking. As far as size go, the boom itself is about 50 metres long, so it's about the size of an Olympic swimming pool. Mechanical engineers design things on stacker reclaimers such as the conveyors. They also design all the drives that allow the machine to move and to rotate and lift the boom up and down. I think all big machines like these are very much really show you what engineering can do, and that engineering is all about people working together. It's a lot of fun actually.
Jonathan Wang is a young Australian engineer specialising in high-rise buildings. He's employed by an Australian company but has worked on cutting-edge projects all around the world. The Latitude building in Sydney CBD was one of his major works.
My role in this building is to design the vertical element of the building, okay, the columns. I came up with the way of how to build the building.
The building stands 52 floors, or 211 metres tall.
It's great to be back here to have a look at a finished piece, and I'm very proud of this project. It's really, really good.
Jonathan is currently working on the Burj in Dubai. When complete, it'll stand more than 600 metres high and will be the tallest building in the world.
My role in this project is, number one, is to complete the structural analysis of the building. Anything to do with the stability system of the building, that's my responsibility.
Jonathan is involved in wind tunnel tests to make sure the building will withstand massive wind forces above 300 metres.
It actually gives us a level of comfort to understand what the building will do when the wind hits it.
He'll spend several years overseas while working on the Burj.
Well, living in Dubai is quite an experience actually. Certainly it's a good one. It's a lot of fun, meeting different people. It's kind of cool. What I really want to do is to do something which has never been done before. Certainly going the tallest, the biggest. It doesn't probably match, in my terms, it probably doesn't match the funkiest, the coolest.
Jonathan is currently working on buildings with no form or set shape.
I'm actually involved in quite a few of all this kind of crazy building, if you like. I've actually designed a twisting building. I think people have a wrong perception about what engineering is all about. I think engineering is, it's actually a very creative thing. What kind of person makes a good engineer? I think you have to be creative, a little bit crazy maybe, dare to challenge yourself. I think one thing I would really emphasize is make your imagination become a reality and make it happen.
You need to have common sense, you need to be keen to be challenged.
Engineering is really about problem solving, and being able to get out there and see where the issues are and sort a solution out is probably a very important skill.
Absolutely love it.
Why?
I'm an acoustic engineer.
So it's actually, you're using your intelligence to give something back to people. Maybe it sounds a bit noble, but that's what engineering is all about, making things happen for people.
So if you think you might like a career that combines creativity and science and working with others to come up with clever solutions, and could see you working on anything from the world's tallest building to a sound studio, a sports venue, or even a roller coaster, anywhere in the world, then think about a career in engineering.